Okay, the first section under qualitative analysis is called acidic radicals analysis. Let us first understand what is meant by this term qualitative analysis. The term qualitative means finding identification of the ions given in the salt. So practically, you will be given a salt in laboratory and you have to identify which are the radicals present in them. So we understand, first of all, what is meant by a salt. Now you are aware that whenever an acid is treated with a base, the product is called salt. Now in acid, whatever radical you can see, for example, in HCl, I can see a chloride radical over there. So we will call this as the acidic radical. So in simple language, whatever you see under the anion part will be called as acidic radical, and whatever you see as the cationic part will be called a basic radical. So in simple language, cations will be called in the salt as basic and anions will be called as acidic. Now this qualitative analysis, what we see, is classified in different manners. But the kind of two types which we are studying are macro analysis and semi-micro. Macro, both these names are according to the sample size which we are taking. So 0.1 to 0.5 gram sample size when you are testing, it's called macro. And much smaller than that, around 0.05 gram sample is called the semi-micro analysis. So this slide is basically about the general introduction to what is meant by qualitative analysis. Now we will begin with proper acidic radicals analysis. For our understanding, we are dividing this in two categories. Group number 1 are those radicals which can react with dilute hydrochloric acid or dilute sulfuric acid. Now, which are they? Let us see the names or formulae. Carbonate, sulfite, nitrite, and acetate. The second category of radicals are the ones which react with concentrated sulfuric acid. And they are chloride, bromide, iodide, and nitrate. Under group 2, you have only one radical, which is sulfate. So our portion is basically all these radicals, how to identify them in practice. In practical, how to identify them. Fine. Let us begin with each and every radical now. Now, whatever chart I gave you, let us understand this in detail. When we take a solid salt and react it with dilute HCl or dilute H2SO4, you will find there is a gas evolved. If there is a gas evolved, you call it as group 1 class A. If there is no gas evolved, it will be group 1 and class A or class group 2. Let us go in detail about if gas is evolved. If gas is not evolved, it's very simple. Gas evolved is suppose colorless gas. Then we have different possibilities. Possibility number 1 is, let us see brown gas wala thing first. If a brown colored gas is involved, that gas is passed into potassium iodide and starch drops are added. The entire solution turns bluish in color. This is a test to detect NO2 minus radical, nitrite radical. When colorless gas is there, there are different smells possible. If it's only effervescence, by effervescence we mean bubbles, and those bubbles turn lime water milky, that radical becomes carbonate. If it is a rotten egg smell, which turns lead acetate paper black, it is sulfide. If it is a pungent smell turning potassium dichromate green, it is sulfide. And if vinegar smell, then it is acetate. So from this particular slide, you are supposed to remember, according to the smell, or some special characteristic of a gas, how to recognize the radical. Now, of course, this is a quite rough kind of a chart. We will now go in individual details of every radical. Let us begin with our simplest of all radicals, that is carbonate. So first, let us give how to go about the test. If we take solid salt, which will contain carbonate, we will treat with dilute sulfuric acid. If it evolves carbon dioxide, that means we will see effervescence or bubbles, then it is passed through lime water. Now, what is meant by lime water? Calcium hydroxide. We will get white precipitate. You know, in school, this was told to you as lime water turning milky. By milky, we mean calcium carbonate precipitate is produced. Now, for this part, this is the kind of reaction given in your book. So you will see for each radical, a set of reactions are given. Now you get two kinds of questions in exam. Either they may ask you directly a reaction set, or they will just give you the test about white PPT is obtained, carbon dioxide is evolved, find out which is the radical present here. So most of the time you will get a test mentioned, and from the test you need to identify the radical. Let us continue ahead. This carbon dioxide gas, if you are passing in excess of lime water, almost more than a double quantity of lime water, whatever precipitate was produced will get dissolved. Now, this particular reaction is this way, that calcium carbonate in presence of carbon dioxide produces calcium bicarbonate. This whole thing is known as test of carbonate radical. Go through the whole chart once again, and red colored boxes, what you see, these are the NCERT actual reactions. In our synopsis, you will find these reactions given under every radical. For quick revision, whatever charts I'm giving here, arrows and all, that you can remember for exam for quick review.
So on the last slide.
The previous gas wala slide. Yeah.
So for both yes and no, it's group 1 and class A.
This is group class B.
Okay.
Class B. Okay. Any doubt for anybody over here? This part is clear. You can ask me the doubt also, no problem. This is the simplest of all the radicals, test of carbonate. Let us go ahead for the second one, sulfide radical. Similar procedure. We will take the solid salt sample given to us, treat it with dilute, either sulfuric, or in exam they may say HCl also, it gives the same effect. This releases H2S. Now, if you remember from the first slide, this is called rotten egg smell. So you will get a rotten egg smell here. And when you pass this in lead acetate, you get a black precipitate of lead sulfide. So to show the chemical actual reaction, you can see these are the reactions. Now, whatever is given here as sulfide, it is written here as Na2S. So Na2S is taken in form of sulfide. Na2SO4 and H2S. So this is the part which you can see written over here. Lead acetate is this one. And black PPT produced is this one. So from the NCERT reaction, I have picked up the important things and made this kind of thing. So for exams, that is rather first important. Okay. For sulfide onwards now, you will find a different thing. You will find one test which is known as dry test. Dry test means you will directly take the salt and carry out a reaction. Then you will have another test with solution. So you will take the salt, dissolve it in water, and make this solution. And do another test which is known by the name confirmatory test. So let us see now what is a confirmatory test given here. This is treated with ammonium hydroxide and a chemical called sodium nitroprusside. This will give you purple color of this particular compound. If you remember your chapter of coordination compounds, sodium nitroprusside was asked over there. Now this is what you see at sodium nitroprusside. So this is your reagent formula. This is sulfide from the solution. And if you see this sulfide radical get introduced inside the coordinate bracket. This is the purple colored compound what you see. Go through both the tests. Now here onwards you will always have one dry test and one solution test. Only for carbonate radical there is no solution test given.
So, do we
Yes.
have to learn the reactions also?
Reactions is main thing. Two things I was just going to say. More than reaction, reaction तो आपको करना ही पड़ेगा, लेकिन ज्यादा उससे इंपॉर्टेंट क्या है, ये जो कंपाउंड आप देखोगे ना, इसके IUPAC नेम. Once I share this file with you, PDF, make in your notebook a list of all these coordinate compounds and write them down. In PYQs, you will find these compounds have been asked again and again, and there are so many coordinate compounds in this whole chapter. Rather, today's lecture, you will find large number of coordinate compounds. So try to make, अगर नहीं आता है, you can ask me as a doubt, whichever you are not getting. ये आपका एक coordinate का revision भी इसमें अच्छा हो जाएगा. Let us come to the next one. This is called sulfite radical. Once again, one dry test and then solution test. So solid salt treated with sulfuric acid, you get sulfur dioxide smell. So this sulfur dioxide smell is also known as burnt sulfur smell. If you burn sulfur, raw sulfur, it actually gives you sulfur dioxide. That smell is called burnt sulfur smell. Now, this is the reaction you can see of the first part. Solid salt is this one, treated with sulfuric acid, and sulfur dioxide you can see here. You know, most of the byproducts are dissolved in water or they are solid formation, so we don't give any importance to them. Next, this sulfur dioxide is allowed to pass through potassium dichromate. Potassium dichromate. Usually, a paper, normal filter paper, is dipped in dichromate and is held over a test tube. Green colored chromium sulfate is produced. You can see this way. So what they do, you know, I'll just draw a diagram and show it to you. In a test tube, suppose reaction is going on, and from here, sulfur dioxide gas is coming out. So they keep a paper, filter paper, dipped in potassium dichromate over here. So the moment it reacts with it, chromium sulfate is produced, and this paper turns greenish in color. This kind of reaction practically is carried out. Any doubt in this thing? Go through first test, which is dry test. Next is a solution test. So salt solution is treated with a reagent called barium sulfide. Now this gives you, first of all, white PPT of barium sulfide. It is treated with dilute HCl. It evolves sulfur dioxide gas. Another part of this PPT, if treated with sulfuric acid and potassium permanganate, the color of potassium permanganate disappears. It is due to this particular big reaction set. Let us go through this part. First section from here. I will start with this one. Na2SO3 is the solution which you have taken. This is the solution which we have taken. We have treated with barium chloride. This is a small correction. This should be barium chloride. which will give you barium sulfite as a precipitate. This precipitate is divided in two portions. Portion number 1 treated with HCl. So very simple reaction. BaSO3 with HCl gives you sulfur dioxide gas. On the other hand, if it is treated with KMnO4, first sulfuric acid converts SO3 into SO4. That sulfuric acid once again react with permanganate to release oxygen atoms. Those oxygen and water will convert SO2 into H2SO4. Now, in this process, potassium permanganate, which was purple in color, has become now colorless compound because potassium sulfate and MnSO4 both are colorless. So that loses the color of potassium permanganate. Once again, look at the scheme carefully. See if you have understood this. It's a bit complicated one. Ensure you have understood before I go ahead.
So does barium sulfate undergo anything further?
Barium sulfite or sulfate, which one you're saying?
Sulfate.
Where is barium sulfate here?
So in the first step of decolorize KMnO4.
This barium sulfate is gone. We are focusing on SO2 for the reaction sake.
So isn't barium
Barium
sulfate
sulfate is a,
PPT?
no, it's a white PPT. It will
Yeah.
remain in the test tube. And see, the meaning is this way. You got from the first reaction two main compounds, barium sulfate, water, and SO2. In that, SO2's oxidation is done by purple colored KMnO4. That's why KMnO4 lost the color. Barium sulfate has no role in it. So our target compound is sulfur dioxide.
Thank you, sir.
So let us go to the next one. That is test of nitrite. There is a small correction in this one. This is NO2 minus NO2. NO3 nitrate will come later. Now we take once again solid salt, treat it with sulfuric acid, and you get brown colored NO2 gas. Now the reaction set, the reaction although looks very simple one, it's a bit complicated, you can see. This is the salt taken, that is NaNO2. When you treat with sulfuric acid, you have to focus on main part, that is nitrous acid. Nitrous acid is a bit unstable compound. That HNO2 then decomposes to form nitric oxide. And this nitric oxide on aerial oxidation gives you brown gas. This is a kind of a mechanism you need to remember. If they want to set a difficult question paper, they can give you this chain of reaction and give you as this as A, this A giving B, and this B giving C. This kind of difficult questions can be set on this part also. That is why just remembering color is one part and remembering reaction set is also required. Let us go for salt solution test. This, when treated with acetic acid, Ki, and starch, can give you blue colored complex. Now, what is this reaction? Is this way. Salt solution is NO2 minus. With first reagent acetic acid, it once again becomes HNO2. This HNO2 now reacts with reagent number 2, that is Ki. Converts itself into iodine. This iodine now combines with reagent number 3 and produces blue colored compound. See if you have understood all the things. This is your NO2, first combining with acetic acid to form nitrous acid. Nitrous acid combines with second reagent Ki. Ki gets converted into iodine. Iodine combines with reagent number 3 to form blue complex. This is one confirmatory test or one solution test. there is another one. This salt solution is carried out with a test known as grease-Ilosway test. This is a test carried out with a chemical 1-naphthylamine, and it produces red azo dye. Now the reaction set of this one I'm showing on the next slide because it's a bit complicated one. But just understand so far whatever is done. Then the grease-Ilosway test I will show on the next slide. NO2 minus also shows a test known as brown ring test, which is discussed later on under NO3 minus. On this slide, any doubt, please ask me before I go to the next one. So let us understand this particular test, the grease-Ilosway test. Our radical is NO2 minus. First, treats with acetic acid once again to convert into nitrous acid. Let us understand this particular chemical. This chemical originally is this way. They have shown the format which is changed. Anybody remembers the name of this compound? This is the original format which is reacted with acetic acid. This H plus has gone here to form NH3 plus, and acetate ion has remained here as bipolar ion. Anybody knows the name of this particular compound? Okay, can anyone recollect what is benzene ring SO3H? Have you heard this compound before? Benzene ring SO3H. Yes. Nobody knows? Okay. This compound is known by the name sulfanilic acid. Sulfanilic acid. The original compound which I have shown here, okay? Sulfanilic acid. Now, this sulfanilic acid, what you see here, is converted into this format, as I've shown, with the nitrous acid produced from here. It undergoes what is known as diazotization. You might have heard this in phenol chapter, amines chapter, everywhere. This is this diazotized group created, diazo linkage. This diazo linkage now reacts with 1-naphthylamine. It forms what is known as the red azo dye. So for simple purpose, you can remember the previous thing what I told you. In case they ask you a difficult reaction set, it is present with you. Let us take up the next in that list, that is acetate radical, one of the easiest one. Solid salt, when heated with sulfuric acid, it releases acetic acid. You know, that will give you, first of all, the vinegar smell. यहाँ पे आपको vinegar smell आएगा. Then you can further treat it with ethanol, which will give you fruity odor, because that gives you esterification reaction. So in the second set, esterification takes place and you get ethyl acetate's fruity odor. Coming to the second part, that is salt solution is treated with neutral ferric chloride and it generates brown red precipitate. Now you can see this is the actual reaction taking place. Salt solution is this one. FeCl3 gives this, which forms a temporary complex like this, which is further undergoing hydrolysis to form brown red precipitate. I hope you understand the importance of remembering so many coordinate complex compounds. Now, those who attended from beginning, we had done group 1 class A compounds that ends over here. These are the compounds which were reacting with mostly dilute sulfuric acid. Now we come to the reactions where sulfuric acid can be concentrated and they show the reaction. Under that, the first one is chloride. Now I'm giving you separate slides here because they are a bit complicated than the earlier ones. Dry test and then solution wala wet test. So if you take solid salt, treat it with sulfuric acid, it releases HCl gas. When treated with ammonia further, white fumes of ammonium chloride are seen. Correction over here, this needs to be concentrated. So what is the reaction set involved? Very, very simple. Solid salt is this particular one, treated with concentrated H2SO4, and that gives you the HCl, which reacts further. Another option for the same reaction, solid salt might be treated with manganese dioxide and sulfuric acid. Now this becomes a much stronger oxidizing agent. So instead of HCl, you get chlorine gas pungent fumes. This is a reaction set for dry test. Let us come to the wet test now. That means with solution. First, we treat with silver nitrate. Being a chloride ion, it will give you white PPT of AgCl. If you react this with ammonium hydroxide, the precipitate dissolves because it forms this complex. So the actual reaction is like this, you can see. यहाँ पे correction ऐसा है, ये bracket यहाँ पे होना चाहिए, chloride is outside. At some places, they only NCERT only has given IUPAC names, so वो आपको easy हो जाएगा. जिनका नहीं है आपको create करना पड़ेगा. Another test you will recall, क्योंकि हम लोग ने ये P block में किया हुआ है, sorry D block में किया हुआ है. This is dichromate sulfuric acid producing red fumes of chromyl chloride. This is the chromyl chloride structure, which when treated further with NaOH produces sodium chromate, yellow solution, and this can be tested in two ways. Either treat with lead acetate, it forms lead chromate yellow PPT, or test with acid amyl alcohol and hydrogen peroxide, it gives you CrO5. Now this last part of this solution part, इनके reaction मैंने next page पे दिखाए हैं because it's a whole lot of reactions there. Go through this before I show you that next slide. Those who want to do this topic seriously, they should really write down all the things what you see on the slide once or twice. Otherwise, ये topic नहीं आएगा. And when you write it once, after that, go for solving PYQs of this. Each and every PYQ you will be able to solve if you know all these charts very well. These are the reactions. First for the lead chromate part and second for CrO5 wala part. This reaction set is exactly same we had done in D block. दोनों same reaction set है. So let us come to the tests for bromide. Once again, we do dry tests first. If you take solid salt and treat it with, once again, यहाँ पे correction वही है, concentrated sulfuric acid, you get reddish brown fumes of bromine. And once you treat with a stronger oxidizing agent, you get little more intense reddish brown fumes of bromine. दोनों में product almost similar है, only byproducts are different. Let us go for the wet test. So salt solution is first treated with silver nitrate. ये set आपको एकदम chloride जैसा दिखेगा. You get AgBr pale yellow PPT. But when treated with NH4OH, PPT dissolves with difficulty. For the reason you are getting here silver bromide, and silver bromide is quite a sparingly soluble salt. So due to its high value of KSP, the solubility in NH4OH becomes a problem. Then you have another test which I think you will perform in your practical soon. That solution is mixed first with chlorine water and then chloroform or carbon tetrachloride is added. You get yellow layer of bromine. Now this is actually a photograph of how the test looks like. So all the bromine gets collected and settles here down. So this is actually carbon tetrachloride plus bromine. And this is the pure water from the reaction left over. This is known as the yellow layer bromine test. Now, a very much similar set is for iodide. You will find tremendous similarity. Solid salt treated with, once again, concentrated sulfuric acid. Deep violet fumes of iodine are created, which when passed through starch solution gives you blue coloration. And this solid salt, when treated once again with a stronger oxidizing agent, you get intense violet fumes. Bromine set is almost repeated over here. And even the next wet test part also you will see quite a repeated one. Salt solution is treated with silver nitrate. Yellow precipitate of AgI is produced. With excess of NaOH, PPT is still insoluble, once again due to high KSP value. And when treated for chlorine water carbon tetrachloride test, it gives you violet color. Now in the photograph, you can see this is iodine, which is dissolved in organic solvent. And this portion is the aqueous part. So CCl4 is water insoluble, immiscible rather. So that's why it has created two different layers. We are left with only two radicals and that will complete our acidic radical set. So we have nitrate, that is NO3 now. And first we do dry test here. Salt is treated with concentrated sulfuric acid. It releases HNO3, which when treated with copper strip, you are actually given copper pieces in practicals. It gives you nitrogen dioxide brown gas. Along with that, the entire remaining solution becomes bluish in color. So you can see the reason for that. Brown fumes are due to NO2 and blue color is due to copper sulfate. So if you trace back the whole thing, this is your main radical NO3 minus getting converted into HNO3. Trace where NO3 is going. This HNO3 now produces what? Nitrogen dioxide and oxygen. Now this once again second lot of NaNO3 will react with this copper, and this NO which is produced here will get converted into NO2. So brown fumes are due to two reasons. One, NO2, and blue color due to copper sulfate. Let us come to the wet test, and this is a very famous test known as brown ring test. You are taking NO3, salt solution, add first few drops of concentrated sulfuric acid, add freshly prepared ferrous sulfate, and this ferrous sulfate in some time give you the brownish colored ring. So FeSO4 is added very carefully through the inner wall of the tube, and dark brown ring is produced. This is a kind of actual photograph of the test tube. Now we see the mechanism of this reaction. The brown ring, what you see is this one. Now in coordination also, they ask a question on it, which I'm solving over here. This is an actual reaction occurring. You have Fe+2 over here. And this NO, nitroso, is the ligand which has a lone pair. This lone pair is given here. This is that coordinate bond which is produced. So Fe becomes +1 in this particular set. Just a caution note. Few nitrate ones don't show this reaction: calcium, barium, and lead nitrate. Because in the process of reaction in the first step, they combine with sulfuric acid and they cannot show the brown ring formation. Let us go to the last radical of this topic, and then we will start with basic radicals analysis. This is a very, very simple one. It first of all doesn't have any dry test. It has only wet test. So salt solution is first treated with barium chloride. It forms barium sulfate white PPT. And if you want to repeat with another one, it reacts with lead acetate also to form PbSO4 white PPT. Now in basic radicals analysis, when we will study, the steps are going to be totally different than what we did under acidic. Basic radicals analysis, first step will be called a dry test. We begin only with dry test, and dry tests which we are going to study in our course are 5. First is color test. Second is dry heating test, flame test, borax bead test, charcoal cavity test. Once we finish dry test, then we go for what is known as a group analysis. And after that, we go for what is known as CT or confirmatory test. So our topic will be divided in these 3 sections. So first we begin with the 5 dry tests one by one. Dry test number 1 is color of the salt. For me, it is really very simple. Just to show the information, you need to remember all of this. So most of the time from the salt color, we have to recognize the compound. So in questions like JEE, they ask you that there is a bright green colored salt given. So if you remember, basically bright green is nickel. You can solve that question much faster with a trick. So for that purpose, salt colors need to be remembered. Dry test number 2 is heating in dry test tube. We take a dry test tube, we heat it completely by taking salt in it. And after heating, looking at the color, we understand which salt it can be. So there are 2 kinds of color. Immediately what we see is the color, what is known as color when hot. So for example, over here, when you see, color when hot means the first impression what you will see. And after some time, when it has become cold, what is the color? So both the ways you can see, there are tests given. Now in these radical tests, what is an important instrument we use is a Bunsen burner. Now, I think all of you must have seen a Bunsen burner in laboratory. We have to understand some portions in them. Portion number 1 is this particular tip of the flame, what you see, this one. Now over here, you will have maximum temperature of the flame, and fuel used is oxygen. There are 2 more portions. One is called the outer cone of the flame. Now over here, amount of oxygen is much more than fuel. Their complete combustion of the fuel takes place, and this part of the flame is called oxidizing or non-luminous flame. While the inner core of the flame, what you see, all conditions are completely opposite. You can compare all the words written over here and see what I mean by that. So for examination purpose, you can remember this part, and this you can generate automatically. In PYQ, when you see, one question has been asked on this diagram, and that was this particular one. So what they had done, they had labeled portions like A, B, C, and they asked which of the following portions have highest temperature. The answer was this one, B portion. So they have not left even this part. ऐसे इस part में भी question पूछा हुआ है, diagram based question आया है. Using the flame, we do a test known as Bunsen burner flame test. Now, how do we carry out it? Let us see the procedure. We use an instrument known as a platinum wire. You get this in market on any stationery shop. You have to make the circular loop at the beginning of the platinum loop. Dip it in hydrochloric acid and salt paste. अभी जो paste लिखा है, paste मतलब आपका salt sample mixed with concentrated HCl. That's called a paste. And it is heated in the central portion of the flame. Depending on the radical, the flame changes the color. Understand? We have to see color of the flame. And that flame color tells you which radical might be present. 2025 का JEE का क्वेश्चन आया था यहां पर. Salt is treated for flame test. It shows a green flame with blue center. Identify the radical. Very clear questions come and they directly use this NCERT language. So remember these slides as it is. You will get your questions done very easily. Fourth test is known by the name borax bead test. We had studied this bit of it under group 13 elements. Now what they do is this way. They take borax. This is step number 1, I can say here. Borax is Na2B4O7. This is heated strongly in the flame. Completely water molecules are lost and you get anhydrous borax. Step number 2, when you continue heating further, it gives you a combination of two chemicals, which is known by the name borax bead. Important portion is B2O3 is the only part which actually reacts with the metal. So you can see a metal is taken, for example, copper. It reacts with boric anhydride and it gives you bluish green colored bead. So this bead, what you have taken, will turn the color. Do not get confused. The earlier test, it was flame color which we was checking. Here, the platinum loop bead color we are checking. So these are the 4 radicals kept in your syllabus with their particular colors. Next dry test is called charcoal cavity test. Now what we do under this is we take a metal salt, mix it with sodium carbonate and heat it. It forms metal carbonate. When it is heated further with charcoal, you get metal oxide. We need to check the color of it. This is a kind of a procedure NCERT has shown. So using a bent tube, they turn the flame onto the charcoal and they heat it. Now, if the metal oxide in this step comes out to be white in color, then cobalt nitrate solution is added on it and you get पर्टिकुलर प्रोडक्ट जिसका कलर आपको चेक करना है. नाउ सी हाउ टू रिमेंबर इट. Pb plus 2 is giving you yellow color when hot, it becomes gray when cold. Since both of them are colors, we don't have to perform cobalt nitrate test. Copper over here will give you red color, so we don't have to perform cobalt nitrate test. When metal salt is aluminium or magnesium, they give you white color over here in the charcoal cavity. So you need to perform second step for them, and they will give you different colors after cobalt nitrate. These 5 steps are called dry test. This was our step number 1. We come to step number 2 now, which is called group determination. What you need to remember in this one will be a reagent and which precipitate is obtained. So let us begin. The first group is known by the name zero group. Please remember, these group numbers are not periodic table group numbers. They are just given randomly 1, 2, 3, 4. So group number 0 is a radical ammonium radical, and it treats with Naessler's reagent to form brown PPT. Group number 1 contains Pb plus 2, which combines with HCl and it forms PbCl2. When copper is present, the real reagent is H2S. But we need H2S concentration in smaller quantity. That is why hydrochloric acid is added, and due to common ion effect, H2S concentration decreases. The precipitate obtained is copper sulfide. Now over here, you will see reagent, group reagent is actually H2S, and HCl is the helping reagent, as you can see. Group number 3 contains 2 different radicals, aluminium and ferric. Both of them are going to react with group reagent NH4OH. The common reagent otherwise is NH4 plus, which goes for common ion effect. And both of them give you corresponding precipitate. These colors of precipitate we will do in the topic itself. This is just a summary kind of table we have made. Next group set is group number 4, which contains zinc and nickel. Their group reagent is H2S, and they give you white PPT or black PPT of sulfides. Group number 5 is calcium, barium, and even we will do later on strontium also. The group reagent is ammonium carbonate, and white PPT of either of the carbonate is obtained. And group number 6 is magnesium. There is no precipitate, it's just a direct confirmatory test you have to do. This classification of groups has been done on increasing KSP values. So group number 1 has the lowest KSP, then 2, then 3, and so on. Let us come to now one by one group radical test, and that we will complete our entire basic radical analysis. First is group 0, which is of NH4 plus. Understand one thing, that 0 group test is performed in the beginning itself, because this doesn't fit as any radical test at all. So solid salt is first treated with NaOH, ammonia gas is evolved, and when treated with HCl, gives you dense fumes of ammonium chloride. Very simple dry test. Here also I am keeping the same strategy. The box which you see are NCERT reactions. Now we come to the wet test further. So in the wet test we have salt solution treated with Naessler's reagent, Now Nestler's reagent is this compound K2HgI4, which gives you brown precipitate of a compound looking like this. Now this is a compound called basic mercury amido iodine, and this compound has this particular structure. Let us come to now analysis of group 1. Now group 1 contains basically 3 radicals: Ag plus, mercury, and Pb plus 2. Ag plus and mercury tests we don't have in the syllabus, so I will not talk about them. We will talk about Pb plus 2. But how to identify whether silver or mercury is there, that they have kept in the course. So salt solution is first treated with HCl. You will get a white PPT. Whether it is silver, mercury, or lead, precipitate is white only. This is added with hot water. If this precipitate is insoluble, it means it is either silver or mercury. If the precipitate is soluble, becomes soluble, it is lead. Now in that insoluble PPT, we add excess of ammonia. If it dissolves, then it is silver. If still it doesn't dissolve, then it's mercury. Now what we are going to do is only tests for Pb and no test for silver or mercury. So let us understand lead test. We take salt solution of lead chloride and do 3 different tests. First, with potassium iodide, it will form PbI2. This is a yellow PPT. Second, we can treat with potassium chromate. It forms lead chromate, which when further treated with NaOH, PPT dissolves. So there are 2 reactions shown here. One, first forming lead chromate, and second, forming the soluble precipitate. Next, this PbCl2 can be treated with sulfuric acid. It forms white PPT of lead sulfate. And in case you treat further with ammonium acetate, it forms the soluble precipitate. This we are doing under group number 1, testing of Pb plus 2. Now, group number 2 involves so many radicals. It once again involves lead, copper, once again mercury, and cadmium. The group reagent used here is H2S and HCl. Now, any of these radicals, when treated with H2S and HCl, if you get a black PPT, it might be lead, copper, or mercury. If you get a yellow PPT, it is definitely cadmium. This H2S which you use here is produced using what is known as a Gibbs apparatus. This Gibbs apparatus looks like this, and it involves basically iron sulfide, stones of iron sulfide treated with sulfuric acid, and it releases H2S gas, which comes from this tube over here. They have, asked earlier diagram based question. So this is another diagram in the book. So I'm giving you a part on that. In my next lecture, I will be keeping a DCT on this in the class only. So once you get this, once your Sunday AITS and all is over, please start preparing for this topic. Next week, when we meet in the class, we will be having a test on this part. Because this topic, if you keep it lightly, you will never understand anything. Those who have taken this topic lightly, they have not attended the class, or they have left the lecture in between, they are definitely not going to do anything in this topic. Because attend karke bhi itna simple chapter nahi hai. It's so much heavy things to remember. Next is lead particular test Pb plus 2. Now there is a sequence of reactions given here. First, understand the sequence. Solution contains Pb ions, which when treated with H2S forms lead sulfide. This when treated further with HNO3 forms lead nitrate. अभी इसका रिएक्शन क्या है, पहले सीक्वेंस देखो. Then treated with sulfuric acid and that gives you lead sulfate. So यहां से यहां तक देखो रिएक्शंस क्या है. This PbS is over here, this one, getting converted into lead nitrate and sulfur, which when treated further gives you PbSO4 white precipitate. This is further treated with ammonium acetate and it forms the clear solution of this complex. इसका reaction यहां पर है and you have the IUPAC name also written over here. This clear solution, when further treated with potassium chromate, gives you yellow PPT, or with potassium iodide, yellow PPT of lead iodide. अब यहां पर दो reactions हैं. So one reaction of this part, second reaction of this one. Under group number 2A, you have another radical and that is copper. सबसे खतरनाक टेस्ट सेट है, केयरफुली वॉच करो. कॉपर सल्फाइड इज टेकन एंड ट्रीटेड विथ HNO3 where copper is converted into copper nitrate. आपको कॉपर को ट्रेस करते जाना है, कॉपर कहां पे जा रहा है, कॉपर नाइट्रेट. The byproduct sulfur decides the next reaction. So इस रिएक्शन का ये केमिकल रिएक्शन है, देखो ऊपर, sulfur is produced. Those who remember the chapter of redox reactions, यही सब रिएक्शन आपको रिडॉक्स चैप्टर में बैलेंसिंग करने को आते थे. यही रिएक्शन इस चैप्टर के हैं. Going ahead, this sulfur is now treated with nitric acid. It gets oxidized to sulfuric acid. Now once again copper from copper nitrate reacts here. It forms a complex. When further treated with ammonia, forms a complex of copper which is deep blue in color. ये इसका रिएक्शन सेट है. When further treated with acetic acid, breaks down into copper sulfate, and when treated with a main reagent potassium ferrocyanide, it forms a chocolate brown precipitate. In college practicals, they actually perform these particular steps to get chocolate brown PPT as the final confirmatory test. Next, we have group number 2B, which is arsenic. Now, arsenic sulfide is treated first with ammonium sulfide. It forms a compound called ammonium thioarsenide. When treated with HCl, it forms arsenic 4 sulfide. When treated further with HNO3, it forms arsenic acid ka clear solution. When further treated with ammonium molybdate, it forms canary yellow precipitate. Now, up to arsenic acid portion, you have this reaction set and the last reaction separately given below. If you try to read the actual NCERT synopsis, it is really very complex. So try to study this using this PDF only.
So what's the difference between arsenic 4 sulfide and the starting?
Which one? Arsenic? No, it's the same thing. This we have taken from original solution. This we have created. So what we create, that precipitate has importance. Because ये आपका unknown रहता है. We don't know yet whether it is there or not. Suppose ये मिला ही नहीं, That means arsenic was absent. That's the meaning. Qualitative analysis, whether it's present or not, we have to find. It's a same chemical. There is no difference in it. Whenever I'm doing this kind of reaction sequences ना, आपको सबसे ज्यादा इंपॉर्टेंस होता है लास्ट कंपाउंड, उसका फॉर्मूला और उसका पीपीटी कलर. ये बीच वाले जितने सारे होते हैं, वी एक्चुअली नेवर कम टू नो देम. सो प्रैक्टिकली आप जब करते हो तो आपको अमोनियम थायो आर्सेनाइड, ये अमोनियम आर्सेनिक 4 सल्फाइड, ये कुछ दिखेगा ही नहीं. दीज आर काइंड ऑफ mechanisms. As you see in organic chemistry, there is a carbocation created. We never see carbocation. वो आके निकल जाता है. Same way, these in between intermediates we hardly see anytime. So, for example, if I take first set, what is visible to me is this portion and directly this portion. बाकी सब in between mechanism है. तो हम लोग को कुछ समझ में ही नहीं आएगा. By the way, ये 5 है, not 3. This is 5. You can see it over here. If you remember, arsenic show +3 and +5. It's a group 15 element.
So isn't it arsenic 5 sulfide then?
Arsenic 5 sulfide. Yes, you are right. Because AS is +5 here. Sulfide is -2. All these changes I will make before sending the PPT to you. Correction जितना अभी तक हुआ था. My strong suggestion is ये PPT सामने रख के आप अपना एक बार नोटबुक में सब लोग नोट्स बनाओ, खुद से चार्ट क्रिएट करो जैसे मैंने ये किया है. आफ्टर दैट यू डोंट हैव टू सी द पीपीटी अगेन. Group number 3 is having 3 radicals: ferric, chromium 3+, and Al+3. The group reagent here is ammonium hydroxide. Ammonium chloride common ion effect is added just to decrease the concentration of OH-. It suppresses the concentration. So over here we have, suppose, ferric ion taken, treated with H2S. So it forms first ferrous, and oxidation by HNO3 will give you ferric. Now, before testing any group 3 radical, first of all there is a filtrate. Filtrate मतलब पहले solution से जो पहले टेस्ट से जो solution आएगा उसे filtrate कहते हैं. तो group 2 का filtrate and rest of it is group 3. So we will oxidize ferrous into ferric and now test it. So these are the 3 tests carried out. They boil off H2S, they add HNO3, and then they add ammonium hydroxide, ammonium chloride. अगर एल्यूमिनियम होगा तो आपको मिलेगा व्हाइट जिलेटिन लाइक पीपीटी. अगर क्रोमियम होगा तो आपको मिलेगा ग्रीन कलर और स्लाइटली येलोइश कलर पीपीटी. और अगर एक्चुअली Fe+3 होगा तो आपको मिलेगा रेडिश ब्राउन पीपीटी. सो ग्रुप 3 में प्रेसिपिटेट का कलर देख के आपको पता चलेगा कि कौन सा रेडिकल प्रेजेंट है. लेट अस डू नाउ इंडिविजुअल टेस्ट्स ऑफ देम: एल्यूमिनियम, chromium, and ferric. So test of aluminium, it is taken as AlCl3. When you add NaOH, you get this white gelatinous PPT. When you add excess NaOH further, the PPT will dissolve. The chemical reaction involved is this one. Also, another test is done where blue litmus is added. We get red color due to presence of HCl. And when a base like NH4OH is added, aluminium hydroxide absorbs the blue color, and this is known as a lake test. Lake in the sense it floats on the surface. That's why it is called lake test. There is no chemical reaction involved here, so you will not find any box after this. Then comes the test of Fe+3. Fe+3 we have taken as ferric hydroxide reddish brown PPT. So when treated with HCl, forms FeCl3. If you treat with potassium ferrocyanide, it gives you Prussian blue PPT, and when further treated with excess, the Prussian blue dissolves. So remember, this test is for this one, and this portion is here. There is a third test also, where this when treated with potassium sulfocyanide, you get blood red coloration. This is a test set for ferric. Let us come to chromium test. Chromium is taken as chromium hydroxide, and when excess of alkali like NaOH or NH4OH is added, we get this particular compound, which is little bit greenish in color. And when hydrogen peroxide is added or iodate ion is added, product is same, you can see in both the cases. This is a test for group number 3. We have total 6 groups, so we are left with group 4, 5, and 6, and that will complete our chapter. Group number 4 contains a bunch of radicals: nickel, cobalt, manganese, and zinc. We need H2S gas over here for reaction, and to increase the concentration of sulfide, they add ammonium hydroxide in it. So when you treat with H2S, depending on precipitate, you can recognize. If you have black PPT, it might be nickel or cobalt. If it is flesh or pink colored PPT, it is manganese. And if it is a white PPT, it is zinc sulfide. Let us do individual tests of them: zinc, manganese, nickel, and cobalt. So let us start with the simplest one, zinc. Zinc is treated with HCl. It gives zinc chloride. Further with NaOH, white PPT, and further with excess of NaOH, precipitate dissolves. And if this zinc chloride is treated with potassium ferrocyanide, you get a little different color, white or sometimes bluish white PPT. Go through the whole set. 2 reaction sets are there. Next, we come to manganese radical test. So manganese is taken as Mn+2, and with HCl it forms MnCl2. Once again forms white PPT, and on atmospheric oxidation it forms brown color. Now this is a kind of reaction set they have given. We come to last one under this, that is, the third one under this, that is cobalt+2. Treated with HNO3 and HCl, it forms cobalt chloride. And with potassium nitrite, it forms a yellow PPT. It's comparatively a small reaction set. I repeat again, in all these tests, pay attention to the color and coordinate compound names wherever possible. Now, one of the most important, जिसपे सबसे ज्यादा अभी तक क्वेश्चन पूछा है, that is nickel. Nickel is treated first with aqua regia. This is a combination of 1 part of HCl and 3 part of HNO3. This is converted into nickel chloride, and this when treated with ammonium hydroxide and dimethyl glyoxime, it gives you rosy red PPT of nickel DMG complex. Now this is that nickel DMG complex here. Some points which have been asked earlier in PYQ. Nickel forms here a square planar complex. If I just mark it, ये आपको यहाँ पर स्क्वायर प्लेन दिखेगा. ये देखो, ये निकल का स्क्वायर प्लेन है. So it is a dsp2 hybridization. You will find two kinds of rings over here. One type of ring here is this one, this side, which is a 5-membered ring and a 5-membered ring. And here there are two 6-membered rings. But in 6-membered ring, this is a hydrogen bond. Here also, this is a hydrogen bond. So you can see 5-membered ring with proper bonding, but 6-membered ring involve hydrogen bonding. So this is a test for group number 4, nickel.
So is in aqua regia 3 HCl and 1 HNO3?
No. 3 HCl, 1 HCl, 3 HNO3. So let us come to group 5, which is barium, strontium, and calcium. The reagent mainly over here is ammonium carbonate. अब यहाँ पे थोड़ा complicated है, carefully देखना. Original solution is treated with ammonium carbonate. It forms a white PPT. अब ये white PPT किसका हो सकता है? एक तो बेरियम का हो सकता है, स्ट्रॉन्शियम का या कैल्शियम का. This PPT is further treated with acetic acid, and that carbonate reacts with acetic acid to form either barium acetate, strontium acetate और कैल्शियम एसिटेट. अभी इसमें से तीनों में से एक ही रहेगा कोई तो टेस्ट करने के लिए वी डिवाइड दिस इन 3 पोर्शंस एंड देन वी चेक द टेस्ट. अभी टेस्ट कैसे करेंगे देखो इसका. फर्स्ट, पार्ट 1, सपोज वी एज्यूम कि ये बेरियम का है, तो वी ट्रीट विथ पोटेशियम क्रोमेट. सपोज वी गेट अ येलो पीपीटी, मतलब ये सच में बेरियम प्रेजेंट है, एंड द फ्लेम टेस्ट गिव्स यू ग्रासी ग्रीन कलर्ड फ्लेम टेस्ट. अगर ये पार्ट कंफर्म हुआ तो आपको रिमेनिंग 2 रेडिकल टेस्ट करने की जरूरत नहीं प्रैक्टिकली, क्योंकि आपका रेडिकल आपको मिल गया. सपोज ये नहीं वर्क हो रहा है, देन वी चेक विथ पार्ट 2, which might be suppose strontium treated with ammonium sulfate. It forms a white PPT of strontium sulfate. फिर इसी के साथ हम लोग फ्लेम टेस्ट करके देखेंगे, and if you get crimson red color, then we understand it's strontium. पार्ट नंबर 3, अगर ये दोनों फेल हो गए तो हम लोग टेस्ट करेंगे कैल्शियम के लिए. वी ट्रीट विथ अमोनियम ऑक्सालेट. वी गेट व्हाइट पीपीटी ऑफ कैल्शियम ऑक्सालेट. फ्लेम टेस्ट गिव्स ब्रिक रेड कलर, और इस ब्रिक रेड को हम लोग अगर ब्लू ग्लास के थ्रू देखेंगे तो वी विल सी ग्रीनिश येलो कलर. अब यहां पे आपके पास 3 रिएक्शन सेट है. एक है बेरियम का, सेकंड स्ट्रॉन्शियम का और तीसरा कैल्शियम का. सो द एनसीईआरटी रिएक्शन सेट आई एम शोइंग ओवर हियर. व्हाइट पीपीटी जे कौन से हैं या येलो पीपीटी कौन से हैं, आपको फॉर्मूले सबके याद रखने अलॉन्ग विद रिएजेंट्स.
Sir, in this one, like how do we why do we first do the first reaction?
Okay, these are based on KSP values once again. तो इसका KSP सबसे लोएस्ट और इसका KSP सबसे हाईएस्ट. Wherever you have an order, the order is because of the KSP values only. तो इसलिए हमेशा सीक्वेंस सबसे पहले बेरियम, देन स्ट्रॉन्शियम, देन कैल्शियम होता है. अगर बाय मिस्टेक अगर आपने कैल्शियम का ही पहले टेस्ट किया तो यू माइट गेट अ रॉन्ग रिजल्ट. दैट इज व्हाई दैट इज द वे इट इज डन. Last one, that is group 6, containing either magnesium, potassium or sodium. Now the group reagent is sodium hydrogen phosphate, and the solution is treated with sodium hydrogen phosphate. You get a white PPT of magnesium ammonium phosphate. This is the test what you get, and this completes our chapter of entire salt analysis.